This is a rule. It's a rule that assigns to every element in D a unique, think single. A single unique element in R. So each X goes to one Y, right? Each element in the domain goes to one element in the range, okay? The set D of all input values is the domain of the function, and the set R of all output values is the range, okay? So function notation, which you guys know, is super easy. Instead of writing y, we now write f of x, right? So we move from something like y equals 2x minus 3. We rewrite that as f of x equals 2x minus 3. This is function notation, okay? I don't know why my scroll isn't working, but that's okay. Oh, here we go. Okay. Differences between functions and non-functions, okay? Well, notice this is a function because every x goes to one y, right? Every x goes to a single y, right? We're good. It's a function. Boom. Here we're good, right? This x goes to one y. This x goes to one y. This x goes to one y. But wait, we have a problem. This x goes to two different y's. So this is not a function, okay? Because we need each x to go to a single element in our range, okay? Defining a function, example. So, for example, sorry for the shaking in the video. My camera is on a stack of books over my iPad right now. We're struggling here. I'll try to be better. Does y equal x squared define a function? Okay. Yes. Why? Each input gives a single output. Boom. Okay. Now, example 2, which of these is not a function? Which of these is not a function? Let's see. It's the one where you have multiple outputs for one input. And I'll tell you, it's this one right here. Notice. At x equals 0, right? X equals 0 has multiple outputs. It fails what we call the vertical line test, okay? So what is the vertical line test? Oh, they reset all my favorite colors too with the update. Oh, gosh. Okay, well, a vertical line test. A graph defines y as a function if and only if no vertical line intersects, whatever, the graph at more than one point. So notice here, there was 3 points. 1, 2, 3. Those were our multiple outputs, right? Okay, now let's look at domain and range algebraically, okay? Domain and range. So implied domain is just, what is implied domain? That's just think of that as like the domain on the calculator. Okay? That's just the domain when you're doing the algebra problem, okay? That's the domain we're going to do here, okay? What is relevant domain? This is a domain in a word problem, a real life word problem, okay? So you're doing a word problem. Sometimes, for example, it doesn't make sense to have, you can't have, what's an example? You can't have negative time, for example. You can't have negative time in the diver example, right? So let's find the domain of 3 different functions. Now, when we're doing this, there's 3 rules we have to be careful of, okay? There's 3 rules. The first rule, or sorry, 2 rules, okay? Ready? So what can we not do? Oh my gosh. Come on. Okay. What can we not do? Oh my gosh. We can't do 2 things. Okay? We can't, 1, I swear, we can't, 1, divide by 0. And we can't square root a negative. Okay? Those 2 things are mathematically illegal. Okay? We can't divide by 0 and we can't take the square root of a negative. So when we have a function like this, there's no division in that function, right? Okay? So we don't have to worry about this one. Okay? But we do have to worry about dividing by a negative. Okay? So x, what do we know? We know that x plus 3 has to be positive. Okay? I should put this other thing in a box is what I should do. I should put this in a box. Okay. X plus 3 has to be positive. So we need x plus 3 greater or equal to 0. Okay? So we solve and we get x is greater than or equal to negative 3. And that is our domain. X is greater than or equal to negative 3. That has to be true to get an output. If we try to put in negative 4, we will get f of x. Like if we try to do negative 4, it won't work. We'll be taking the square root of a negative, okay? Okay. B. Let's try another. Okay, let's try let's try f of x equals, what is happening? What just happened? Well, I guess this stuff is gone, but that's okay. You can go back if you missed it, okay? F of x equals square root of x over x minus 5. Okay. So remember our 2 things, right? We can't divide by 0, and we can't take the square root of a negative, okay? So we have both of these problems, okay? So we have 2 things going on, right? We have x has to be greater than or equal to 0, right? So what is my domain here? My domain has to be 0 to infinity in interval notation, right? And here, we can't divide by 0, right? So if x is 5, if x equals 5, then 5 minus 5 is 0, and that's bad, right? We don't want that, right? So we have to have x is not equal to 5. What is that in interval notation? Well, that's everything except 5. Now we have to bring those two things together, okay? We have to bring these two things together, okay? Bring those two intervals together. What is the intersection of those two intervals? The intersection is 0, 5, union 5, infinity. That is our domain. Okay. Okay. C. Let's try one with a relevant domain problem, okay? So these two were implied domain, right? These two were implied domain. These two were implied, which will be most of the questions we do. And this one will be relevant domain, okay? Okay, let's try like an area problem. We'll make it a of x, okay? A of x equals, what is happening? Okay, a of x equals, something like the square root of 3 over 4 times s squared, right? Just some number times s squared, s squared, x squared, I'm dumb, times x squared, where a of x is the area of an equilateral triangle with side lengths x. Okay? There's no dividing by 0, right? There's no division in this problem. And there's no square roots. So what even wouldn't be in the domain? Like what would be our restriction on the domain? Well, our restriction is that you cannot have a negative side length, right? So what? So x has to be greater than or equal to 0 because x is our side length, right? So our domain, right? Our domain is 0, infinity. A lot of times when we write the final answer for domain, we write it with a domain. We write domain, and then we write a little colon. Okay, we write it like domain, colon, like that, right? Domain, colon, and then our domain. Okay. Last one, finding the range of a function, okay? Usually you just use the calculator, right? But pay attention, what? Pay attention to vertical asymptotes, right? Pay attention to vertical asymptotes, okay? Those are the key, those will trip you up, okay? For example, if we have the function f of x equals 2 over x, right? And we graph that, it's going to look something like this. So it looks like we're hitting every single y value. We're hitting all the y values up here, right? And we're getting every y value down here, right? So we're covering every y value, it seems like. But guess what? This graph is missing one y value. Sorry. Don't pay attention to horizontal asymptotes. Pay attention to vertical asymptotes. Pay attention to horizontal asymptotes. That's what I meant to say. Because, why? We have a horizontal asymptote right there at y equals 0, right? The graph never, ever reaches that point. So my range is every y value except 0.